We will discuss a very important topic today, that is two-port devices and the hybrid model. What is the meaning of two-port devices and what is the hybrid model to analyze that circuit? What is the two-port device? Let's talk of transformer. What is it? You have current and voltage here and you have current and voltage here. Let's say this is input, this is output. So you have one set of parameters on the input side and one set of parameters on the output side. So this can essentially be taken as a closed box in which we have two ports and in which we have two output ports, two input ports, two output ports. So that type of devices, active devices in which we have two input ports. As a matter of fact, the port is one, but we have 2 points. So that is why it is called one port on this side and one port on that side. Transfer current or to supply voltage, you need one port that has two terminals. So there are two terminals in the input, that is one port, and there are two terminals at the output. So this is one port. So what we get? We have one port here and one port there. This type of network is called or circuit is called two port. So let's draw the block diagram. It's like this. This is a two port device in which we have one port on the left side, that is, let's say, our input side. This is current and this is voltage, and we have two ports here, I2 and this is V2. I have left this place vacant. Why? Because this is two-port active device. What is an active device? What is the difference between an active and passive device? You must have studied. In passive devices, you supply energy. It takes energy and converts it into certain form. That is a passive device. For example, your resistor. What it does? It takes power, it takes current, it takes voltage across it. So that is a passive device. But active devices are those devices that actually transform energy. For example, transformer. It transforms energy into different form. If you have high voltage and low current here, you will get low voltage and high current in the output side, step up, step down and all. Similarly, transistor is an active device. Why? Because we are able to get current amplification, we are able to get voltage amplification, we can get power amplification. So it is an active device. What it takes, it transforms it. That is why transistor is an active device. And because our main topic is BJT, transistor, for which we have to develop certain model to analyze the circuit. We are trying to understand what two-port active device is and how hybrid model is used to analyze this circuit. So let's say this is our two-port active device. What we do? We take the voltage of the input side, that is V1, as a function of input current and output voltage. Similarly, we take the output current, voltage of this side and current of this side, and see the direction of current. This direction is taken positive. So if you have load to this side, then current will be this, and then I2 will be minus IL. So that is to be kept in mind. Now similarly, this is also a function of input current and output voltage. This is the definition. How we do? Let's see. We use certain parameters. H11 into I1 plus H12 into V2. It is a function of I1 and V2. So V1 is H11 I1 and H12 V2. And the second parameter that we take is I2. So this will be H21 I1 plus H22 V2. This is two-port network. This is how we analyze a two-port network. I think this is clear. Input voltage, input current, output voltage, output current. I am using input output, but you can say voltage and current at port 1, voltage and current at port 2. Clear? So voltage of port 1 is a function of current of port 1 and voltage of port 2, and similarly current of port 2 is a function of current of port 1 and voltage of port 2. Clear? This is the equation. Now I am rubbing this. What are these? H11, H12, H21 and H22. These are called hybrid parameters. Why hybrid? Because they are not of similar type. One of the parameters is a resistance, one of the parameters is a conductance, others are just dimensionless ratios. Therefore, this is called hybrid. Clear? Now we will define what are these hybrid parameters. H11. H11 is defined as, this is the sign for defined as H11. See this equation, equation 1. Let's say this is equation 1 and this is equation 2. So you see equation 1, H11 is basically V1 by I1 at V2 equal to 0. That is, if you put V2 equal to 0, H11 will be V1 by I1. And what is the meaning of V2 0? V2 0 means short circuit. The second port has been short circuit, therefore voltage is 0. And V by I is resistance. Therefore, this is input resistance. If you say the first port as input, then this is input resistance with output short circuit. Clear? You have to understand this. When you will understand this, then you will be able to understand the hybrid model of transistor. Clear? Now, second, H12. What is H12? H12 is defined as, see, V1 by V2. V1 by V2 given I1 is equal to 0. Clear? If I1 is 0, this is V1 by V2. I1 0 means open circuit. That is, the input is open circuit. And what is this? See, V2 by V1 will be voltage gain. Then this is V1 by V2 is reverse voltage gain. Reverse voltage gain at I1 equal to 0, or you can say input open circuit, open circuited. Okay, clear? So this is reverse voltage gain at input open. Third one, H21. This is I2 by I1. So H21 is I2 by I1. I2 by I1 at V2 equal to 0. Now, understand this very carefully. V2 is equal to 0. That means output is short circuit. And I2 by I1 is current gain. Output current by input current. So current gain. So this is what? This is short circuit current gain. You must have heard this term many a times. So this is short circuit current gain, a very important parameter. Next, H22. H22 is what? See, at I1 equal to 0, it is I2 by V2 at I1 equal to 0. That is, input is open and I by V. V by I is resistance, I by V is conductance. So this is, and this is 2, the second part, the second port. So this is output conductance conductance at open circuit, at input open circuit. Clear? So we have defined H11, H12, H21, H22, and we saw what their meaning is. Now let's understand one more thing. You must have heard of IEEE. This is the institution that gives standards, the nomenclature for different aspects of electronics and electrical engineering. It defines H11 as I, the input. Okay, or I should say, yeah, fine. Clear? H12, this is what we had seen. This was reverse transfer. So this, it says R, that is HR, reverse transfer. Then H21, this is HR, and what, sorry, HF, HR is this one, this is HF, forward transfer, H21 was I2 by 1, forward transfer, while H12 was V1 by V2, that is input by output. So this was reverse transfer, this is forward transfer. And finally H22, this is what? See, I2 by V2, this is output. So it is denoted by O, output. So this is the nomenclature given by IEEE. So what we can write here is, in place of H11, we can write HI, I1, HR, see I am writing it, V1 is equal to HI, I1 plus HR, V2, and I2 is equal to HF, I1 plus HO, V2. So this is IEEE nomenclature. Clear? Now the next thing about BJT. We use BJT in three configurations: CE, CB and CC. So when we are dealing with a two-port network that is in CE configuration, we use this E in this parameter. HIE means this HI, H11 in CE configuration. So in CE configuration we'll write HIE, HRE, HFE and HOE. In CB configuration we'll write HIB, HRB, HFB, HOB, and in CC configuration HIC, HRC, HFC and HOC. This is clear? Now let's draw the hybrid model for a transistor, which is basically a two-port network. So the model for transistor is like this. This is HI, this is HR, V2 or V output. Let's say I and O, output, this is for output. Then this is let's say this is our V output. This may create confusion. Let's say this is V2 only, V2. So this is HR V2, this is HI, this is our I1, this is V1, this is a voltage source. This is, what was this? If you remember, HF was forward current transfer. So this is HF into what? This I1, and this is HO, that is the conductance. Now if you analyze this, let's see this KVL in this mesh, what we will get? we'll get V1 is equal to HI into I1 plus HR V2, clear? And from there, this is I2, our current. This is, you do node analysis. This is a current source and this is conductance. So this will be, I2 will be equal to this plus this. So what is this? This is HF into I1 and this is conductance. So conductance into V2 is I2. So what, HO into V2. See, we have got our hybrid model for transistor. This is the diagram and you can see the expression for hybrid model. This is exactly what we did in the last page. Last page we had derived this formula from H11, H12 to IEEE nomenclature, this and that. You can compare, they are same. So this is the hybrid model for a transistor. Now we'll enter into the particular configurations, that is common emitter, common collector, common base, and then we'll see what are these parameters and how can parameter for common emitter be derived from a parameter for common base model, that is HIE in terms of base parameters or base parameters in terms of common emitter parameters. That is the part that we will see in the next part.